Welcome to our discussions and thank you for always joining us. We are looking at Form 2 Chemistry, balancing of chemical equations. A chemical equation is a representation of chemical reactions by use of chemical symbols and chemical formulae. When we talk about a chemical symbol, this is a letter or letters that represent elements, and a chemical symbol can either be the first letter of the name of the element or the first two letters of the name of the element, except some few elements whose chemical symbols come from their Latin names, that is, the likes of potassium, sodium, lead, mercury, silver, etc. For a chemical equation to be complete, it must have the correct chemical symbols or the right letters that represent them as symbols. It must have the correct state symbols, that is whether it is in solid, liquid, gas, or in solution, and above all, it must be balanced. We are going to look at balancing by using a few chemical equations we have below. We are going to begin by looking at an equation between hot concentrated sodium hydroxide with chlorine giving us sodium chlorate 5, sodium chloride, and water. We can start by balancing the oxygens. If you look at the number of oxygens on the reactant side, we only have 1, and on the product side, we have 3 oxygen on sodium chlorate 5 and 1 in water. We can decide to use 3 on water, for example, such that the number of oxygens will be 1 times 3, giving us 3, plus 3 from potassium chlorate 5, we have a total of 6 oxygens. And for us to make the number of oxygens on the reactant side, we simply multiply 6 behind sodium hydroxide. From there now we move again and look at sodiums. You look at sodiums on the reactant side, we have 6, and on the product side we have 2. So if we decide to make them 6, we can either multiply 5 behind sodium chlorate 5 or simply 5 behind sodium chloride. But if we multiply 5 behind sodium chlorate 5, we will also disturb the number of oxygens, and therefore we now multiply 5 behind potassium behind sodium chloride for us to balance the number of sodiums. Then now we move and look at the number of chlorines. You realize chlorine on the product side we have 1 plus 5 here, giving us 6. For us to balance chlorines, we simply multiply 3 behind chlorine. Once we have done that, we can now check and see whether our equation is balanced. The number of hydrogens are 6 on the reactant side, and on the product side we have 6. Then chlorines are balanced. We have 6 on the product side and 6 on the reactant side. The number of oxygens are 6 on both sides, and therefore the equation is automatically balanced. Then now we move to the reaction between calcium hydroxide plus chlorine, giving us potassium hypochlorite, calcium chloride, and water. For us to balance chlorines first, we have chlorine on calcium hypochlorite and chlorine on calcium chloride. We have 2, meaning they are what? 4. That means to balance chlorines, we multiply 2 behind chlorine. And now the chlorines are balanced. We can now move to hydrogens. We have 2 hydrogens on calcium hydroxide. We have 2 hydrogens on water on the product side, and therefore the hydrogens are balanced for now. We can now move to calcium. Calcium we have 1, 2 on the product side, and therefore to balance calciums we simply multiply 2 behind calcium hydroxide, and that also affects the number of hydrogens, meaning the number of hydrogens will be 2 times 2 giving us 4, and for us to balance hydrogens we are simply going to multiply water by 2 for us to balance, that is 2 here for us to balance hydrogens. We can now check through and see that the equation is balanced after we have written 2 behind water. We can move to potassium hydroxide. Remember, the balancing of potassium hydroxide with chlorine is the same as that of sodium hydroxide, and therefore we are going to write 6 behind potassium hydroxide. We write 3 behind chlorine. Then we have potassium chlorate 5. We write 2, that is 3 behind the water, and also 5 behind potassium chloride for the equation to be balanced. Then we go to 4, where we have hot concentrated hydrochloric acid with potassium manganate 7 to produce chlorine, manganese chloride, water, and potassium chloride. We can start by making the number of chlorines on potassium chloride even. So we multiply by 2 here. That means we are going to have chlorines, we have 2 here, we have 2 here, and 2 here, giving us 6. We can now consider oxygen. Let us consider oxygen. But before we look at oxygen, by writing 2 behind potassium chloride, we have also made potassiums to be 2. On the reactant side, we also multiply by 2 behind potassium manganate 7 for potassiums to be balanced. Writing 2 behind potassium manganate 7 makes oxygen to be 8, that is 4 times 2. And on this other side, we only have 1, so we multiply by 8 behind water to balance the oxygens. Once we have balanced the oxygens, we can now look at the hydrogens. On the product side, we have 2 times 8 giving us 16. That means we multiply 16 behind potassium, behind hydrochloric acid, for us to balance the hydrogens. From there, we are going to have chlorine will be 16 on the reactant side, and we have 2, that is 4 already. To balance chlorine, in this case, we are going to have to write 5 behind chlorine, 2 behind manganese chloride for us to have our equation balanced. Remember, balancing is trial and error. We can balance using any value, but we try to make the values a bit simpler. We go to magnesium nitride reacting with water to give us magnesium hydroxide and ammonia gas. We can balance the equation first by balancing magnesiums. We have 3 magnesiums on the reactant side, so we multiply magnesium hydroxide by 3, and by doing that we have affected the number of hydrogens and oxygens, and therefore we can try and adjust the number of oxygens. We have 2 oxygens, that is 1 times 2 giving us 2, times 3 giving us 6, and therefore we can now again look at the number of hydrogens. We have 6 already there, but we have 3 here. I usually advise learners to make the number of atoms which form an odd number even by multiplying by 2. So if we write 2 behind ammonia, the number of hydrogens will be 6 here. Then here we will be 6, giving us 12. And for us to balance hydrogens, we write 6 behind the water. And by so doing, that equation is automatically balanced. We can now move to copper plus nitric 5 acid, giving us copper 2 nitrate, nitrogen 4 oxide, and water. So to balance copper, the reaction between copper and concentrated nitric acid, we can write 8 behind nitric 5 acid. And if we write 8 behind nitric 5 acid, we can do 3 behind copper nitrate, then 3 behind the copper. We are going to write 4 behind water, and also 2 behind nitrogen 4 oxide. We move now to number 7, where we have ethanol reacting with air to form carbon 4 oxide and water. Remember, ethanol is organic, and any organic substance reacted or burnt in air will give us 2 products, water and carbon 4 oxide. We can start by balancing the hydrogens. Remember, we have 5 plus 1 giving us 6. So we can write 3 behind water to balance hydrogens. And again, carbons, we have 2 here. We have 1 on carbon 4 oxide, and therefore we can balance carbon by writing 2 behind CO2. And by so doing, we have also affected the number of oxygens. The number of oxygens on the product side, we have 2 on carbon 4 oxide, that is 2 times 2 giving us 4, 10 plus 1 times 3 giving us a total of 7. So we have 1 here. We can write 3 behind oxygen, so that we have a total of 7 oxygens on the reactant side, and that equation is automatically balanced now. That is the last part of our balancing of equations. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two. You click the subscribe button so that anytime we publish a video like this, you'll automatically be given a notification. Thank you and welcome.